in this next section, section 5.3, we're going to be focusing, and this is what we're doing almost all of today here, is we're just going to be multiplying polynomials. Multiplying polynomials. Okay. We're going to start with the basics, and we're just going to keep adding to it and making it more and more complex. So we first begin by multiplying two monomials. Now, we did this in some examples yesterday. Mariah even did that in the problem that she had on the board. Remember that, number 7? Mm-hmm. Okay. And this is what she did. All she did was multiply the coefficients. She multiplied the coefficients. And then you just have to use the product rule. Use the product rule to multiply variable factors. Use the product rule to multiply the variable factors. For example, if we take this guy, 6x to the 7th times 9x to the 5th. We remember, just kind of what we saw with the problem on the board. Everything here is multiplication, right? There's no addition, there's no subtraction. It's all multiplication, which means all of this stuff is stuck together. And since it's all stuck together, you rearrange the stickiness to condense and make it look simpler. For example, I can rearrange so that I have 6 times 9. Because what's 6 times 9?
53.
54.
Oh, 4.
54. And then the rest of this is going to be just a bunch of x's. Well, how much x would I have in this product? How many factors of x would I have here?
12.
I have 12, so that's 54x to the 12.
There was a problem on the first like that.
Yep, we did a problem like that in class yesterday too. I believe the problem yesterday was 6x to the 8th and 8x to the 6th.
Mm-hmm.
So it shouldn't have been a problem, right? Now, since Tosh likes...
No, I do not.
You do like fractions, that's what you were saying. 3/7 x to the 12th and y to the 8th times 5/4 x to the 10th y to the 8th. Now, since I know that certain people will be watching this, because I have some students that say they like fractions as long as they can multiply them, right? Don't you feel the same way?
Mm-hmm.
Okay. So I'm just multiplying these fractions, so how do I multiply them? Flip them. I just multiply straight across, right? Multiply numerators, multiply denominators, so what's my numerator? 15 over what?
That's all you do? Just multiply them? You don't do the least common denominator, none of that?
You don't need an LCD to see, this is the thing. When we get an LCD, that's when we're adding and subtracting, because addition and subtraction is kind of racist. Remember what we said? No, it is. Because think about what are the things that we combine? We combine what? Like terms. We have to have things that are alike to combine them. Right? Look what we had over here. I combined like terms. Did you put x to the 3rd and x squared, did you put them together? No, because they weren't alike, and society frowns upon that. Okay? But you know what? Multiplication goes against all of that stuff. Multiplication is fantastic. I don't care. Oh, you look different than me? We can still multiply together. Easy there. Easy. So, yeah, you multiply the numerators, you multiply the denominators. You get a common denominator when you have to add and subtract. Again, addition and subtraction is more restrictive than multiplication.
So if there's an equal sign, like, if there's a 3/7 equal 5/4, then you would flip it and then multiply?
You don't.
If I just had 3/7 equals 5/4, that would not be true, would not be an equation. Now you could check the cross products to see if you have a proportion, which is two equal fractions. And that may be what you're thinking about. Or if I had 3/7 x equals 5/4, I would multiply times the reciprocal to get x by itself. But here I'm just multiplying. Just multiply. Now how many factors of x do I have altogether? I've got 12 and 10, it's 22. How many factors of y?
16.
I've got 16.
What if you had, for example, 3 parentheses 3, 7, 8, 12, y to the 8th, and then you had a negative 2 exponent on the outside? Would you flip?
Oh, well,
Would
let's see.
you
That's
flip the 3 and the 7 for the reciprocal?
yeah, that's a good question. I think if I'm understanding your question correctly, you're saying, what if I had, let's say 5/9? I'm going to make it like this: x to the 4th, y to the 7th, to the negative 2nd power.
Yeah.
Now, of course, this guy doesn't really pertain at all to what I was just talking about with multiplying monomials. But it's still worthwhile to look at. Now, what we saw yesterday is that when we have a negative exponent, especially when you have a fraction on the inside, go ahead and use that negative to make the guy on the inside the reciprocal. Remember that? The negative exponent, the negative piece, will be used to reciprocate what's inside here. So just flip it over. 9 y to the 7th, 5x to the 4th, and this is now to the positive 2nd power. So I use the negative of that power to do the reciprocal. Okay? And then, of course, you would just finish working this problem out, and you would get 81 y to the 14th over 25 x to the 8th. Do you agree? Okay. Now, since we're on this topic here, we got a little off topic, but that's okay. If you don't like this, skip to the next video. You also could have just applied that negative 2 exponent, and you could have said this. That's 5 to the negative 2nd, x to the negative 8th, over 9 to the negative 2nd, y to the negative 14th, right? Well, we know what to do with those negative exponents. We'd have to move them to the other side. So it becomes 9 squared y to the 14th, 5 to the positive 2nd, and x to the positive 8th.
So basically, you're saving, like, you're skipping a step by just.
Right. No, but it doesn't really matter how you do this because it's all stuck together. It's all to do with multiplication. So you still get the same answer.